This is Alan Samuel Wafula, a math physics teacher, and today I'm going to take you through mathematics, and the theme today is going to be logarithm. So I'm going to handle logarithm at high level or advanced level, which is more like that of O level, but here in A level there are more prerequisites that we add in. So we are going to add in some little knowledge which is far different from that of O level. I know in O level you heard of logarithms, and I know some of the students, when they hear about logarithms, they feel bad. So just for people in A level, we are going to look at something which is not very quite hard, and we are talking about logarithms. As we saw last time in our logarithms, we had seen logs raised to powers with their bases, and today I'm going to deal with something very unique, and that is bases or unknown bases, for example x or y. And how do we play around with unknown base? How do you zero out to get the solution to unknown base? So let's take an example. We can be told that solve the logarithm. That is log of x 27 minus log of x squared 81. This equals to 1. They give us such. We have been used to known bases, but this time they give us unknown base, and that is x. So how can someone solve with unknown base? So here, a bright child will look at the correspondency between 27 and 81. So there's something which is unique, and that something which is unique is 3. So if we decide to change our base from x, which is unknown, to 3, which is already known, how will it look like? Let's try to see it. So here we shall say, changing from base x to base 3, this becomes log of 3, we raise it to 27, over log of 3, now this becomes x. Minus, because of this minus, I'll also change from this unknown base to a base 3. And this becomes log of 3, 81, over log of 3, then that is x squared. But remember, it is equal to 1. Thereafter, we look at this 27 with a 3. A 27, if I try to prime factorize it out, it is a 3 to power 3. Then also, if you look at 81, when you prime factorize it out, it gives us a 3 to power 4. So thereafter, we shall say this is log of 3 to power 3 over log of 3x minus log of 3 to power 4 over log of 3x squared, but this equals to 1. So when we reach there, we apply the laws of logarithms. And what do they say? That if we have a number raised to a power, but it has a power, the power can drop in front. So when you see this 3, when it drops, we shall remain with log of 3, which gives us 1. So here we shall just come up with 3 over log of 3x minus, the same happens here, and this will give us a 4 over a log, even a 2 here falls, that is 2, 3x, and equals to 1. So this is what we have. So then after, sorry for this. Then after, when you have reached from this step here, we can now see that log of 3x is so common. I can now introduce in a new variable, for example, p, by saying let p equal log of 3x. So I'm now letting this to be another variable. So I let it to be p, such that where I see log of 3x, it gives me a p. So this will become a 3 over p minus 4 over 2p, but this equals to 1. So thereafter, I try to see that the common LCM can be a product of 2p and then p. So this will give us a 6p minus a 4p over a 2p square equal to a 1. Making it linear, it becomes 6p minus 4p, which gives us 2p square. When you simplify 6p and 4p, it gives us a 2p, which is equals to p square. So it is so nasty for someone to think that we can divide through by 2p, because when you divide through by 2p, we are eliminating some variables. So here what do? A constant 2 can be divided, but a p we can pull it out. So when I divide through by 2, I'll get p, which is equals to p square. So I'll pull this p to the other side, and we shall have p square minus p equal to 0. So we pull out 1p. So when you pull out a common p, we shall have p minus 1, giving us a 0. So at this level, we have now got two values of p. So we are going to say either p equals to 0 or p equals to 1. But not, our target is not to get p. Our target is to get x. So after we have got these values of p, we go back to look at this equation. As p equals to log of 3x, we are going to say for p equal to 0, then how do we get x? So this becomes log of 3x equals to 0. So here, we shall therefore say that our x is a 3 to power 0, which gives us a 1. So meaning that the value of x is 1. Since we know that any number to power 0 is always 1. Then we shall say for p equaling to a 1, because we remember had got 1. We shall say log of 3x equals to 1. So implying that x is a 3 to power 1. So the value of x gives us 3. Now, the challenge is, how do we come up to conclude the answer of x? Because here they're saying solve for x, meaning we need to get one value of x. But we have got two values of x, whereby we have x as 1 and x as 3. So we go back here. We look at the equation. It is log of x 27 minus log of x squared 81. Now we go back to the principles, the laws of logarithms. What do they say? We know very well that log of 1a is always 0. If a is not equals to what? To 1. That if we have 1 log of 1a, it is always known as 0 if a is not equals to 1. So therefore, when we substitute in here 1, this equation will be invalid. So therefore, this x as equals to 1 is not correct. The only value of x that is correct is a 3. Then we conclude, therefore, x is equals to 3. The mistake comes in here when a student gets two values of x and then says x equals to 1 or x equals to 3. There we shall cross your final work. You'll miss out the final mark. So a student should be right here to know that if I've got two values of x, what could be the best option? If you look at 1, using this law, it therefore shows it is not valid. Thereafter, the only answer for x would be 3. Thank you so much for listening and watching to me. I encourage you to subscribe to Tower Academy for more videos and more lectures. I remain Wafula Alan Samuel, the math teacher.